You are welcome to the Girl Regional Championship. This is the 4th contest from the Ashanti region, and it features Kumasi Sec. Let's meet the contestants. Kumasi Secondary Technical School is represented by
Ahinkra Ejeipoku. Nane Champo Emmanuel.
KNUST Senior High School is represented by
Na Jefferson Mwenkara. James Steven.
Kumasi High School is represented by
Yakubu Abdulmumin, final year. Martins Namponsan Kwabna.
Ejisuman Senior High School is represented by
Kwatin Ebenezer. Gansa Nana Kwame.
Best wishes to all the contesting schools. The Girl Regional Championship is proudly sponsored by GO with support from Joy News. This is a primetime production. I am Dr. Thelmohine J., a senior lecturer at the University of Ghana School of Pharmacy, and I'm your quiz mistress. Some rules of the contest. We'll have this contest in 4 rounds. We are going to start in round 1. Here, I would ask you several questions, all to test your knowledge of principles in physics, chemistry, mathematics, and biology. If a question comes to your school as a main question, you have 30 seconds to give me an answer if there are calculations. If there are no calculations, I'll take your answer in 10 seconds. A correct answer will give you 3 points. An incorrect answer means you make that question available to another school to try for it as a bonus. The first school to ring their bell for that question and gives me a correct answer will get 3 points. If the answer is incorrect, then there's a penalty point of 1. In this round, I'll start with Kumasi Secondary Technical. The contest starts with a preamble to all the schools. An ideal resonant circuit is composed of an inductor of inductance L and 2 capacitors of capacitances C1 and C2 connected in parallel. I'll take it again. An ideal resonant circuit is composed of an inductor of inductance L and 2 capacitors of capacitances C1 and C2 connected in parallel. Kumasi Secondary Technical. Find the natural angular frequency of the circuit if L equals 20 millihenry, C1 equals 4.5 millifarad, and C2 equals 0.5 millifarad.
I have the angular frequency. I have the angular frequency to be 1 by 10 to the power 2 radians per second.
I'll take it. KNUST. Find C2 if C1 equals 5 millifarad, L equals 10 millihenry, and the natural angular frequency of the circuit is 100 radians per second. A bonus to Ejisuman. Okay, I shall allow them. Okay. KNUST.
5.001 millifarad.
That's not correct. I'll allow Ejisuman. I will allow Ejisuman to take the bonus.
10 millifarad.
No. Okay. Kumasi High. Find C1 if C2 equals 5 millifarad, L equals 0.5 millihenry, and the natural angular frequency of the circuit is 200 radians per second. Go ahead.
Okay. You have 50 millifarad.
No. A bonus to KNUST.
45 millifarad.
That's correct. Ejisuman, find L if C1 equals 2 millifarad, C2 equals 3 millifarad, and the natural angular frequency of the circuit is 50,000 radians per second. Go ahead.
The inductance is 0.04 Henry.
No. A bonus to KNUST.
We have to 8.0 by 10 to the exponent negative 8 Henry.
No. So the answer there is 4 millihenry. 4 millihenry. And KNUST, your answer was 5 millifarad. Not 5.00. 5 millifarad. A preamble. Find the equation of of the circle, the expression x minus 2 squared plus the expression y plus 2 squared equals 9. After a reflection, I'll take it again. Find the equation of the circle, bracket open, x minus 2, bracket closed, squared, plus, bracket open, y plus 2, bracket closed, squared, equals 9. After a reflection, Kumasi Sec, in the line y equals
the expression y plus another expression x plus 2. This expression is squared. All this is equal to 9.
That's correct. KNUST, in the origin.
In the origin.
Go ahead.
We have to brackets open, negative x, negative 2, bracket close squared, plus bracket open, 2 minus y, bracket close squared, equals 9.
No. Kumasi Sec.
The expression x plus 2. This expression is squared plus another expression y minus 2. This expression is also squared. All this is equal to 9.
That's correct. Kumasi High, in the x-axis,
we have x minus 2, that expression squared, plus 2 minus y, that expression squared is equal to 9.
Repeat that answer.
So x minus 2 all squared plus 2 minus y all squared is equal to 9.
Yeah, I would accept that. And because of that, yeah, I'll go back and accept KNUST's answer. It's equivalent. So the two answers are the same. Ejisuman, y-axis. Yes.
The expression x plus 2, that's squared, plus another expression y plus 2, that's squared, equal to 9.
That's correct. A preamble. Give one colligative property of solutions. Give one colligative property of solutions. So that's the preamble. All the schools, I want one property each. Kumasi Sec.
They are saturated. That's solutions are saturated.
No. KNUST.
Solvation.
No. Kumasi High.
Okay, we have their solubility.
No. Ejisuman.
Concentration.
No. Okay, so the colligative properties are boiling point elevation, freezing point depression, lowering of vapor pressure, and osmotic pressure. So either of these. Okay. A preamble. Name. So each school should give me one of the four means by which insects communicate. Kumasi Sec.
They communicate by chemicals known as...
It's okay. I'll take that. KNUST. If I allow you, you give all the answers, so it's okay. KNUST.
They communicate by the way they move and touch each other.
Okay, I'll take that as well. Touch. Kumasi High.
Okay, they can also communicate when their bodies come in contact, that is by contact.
No, it's the same as touch. They've said that. Ejisuman.
They communicate through some sounds that they make.
Yes. So the four ways are chemical, visual, by sight, auditory, that's what they said, sound, hearing, and tactile, by touch. Okay? A preamble. The magnetic susceptibility of a paramagnetic substance is 4.0 times 10 to the power negative 4 at 20 degrees. Find the magnetic susceptibility of the substance at the given temperature. I'll take that again. The magnetic susceptibility of a paramagnetic substance is 4.0 times 10 to the power minus 4 at 20 degrees Celsius. Find the magnetic susceptibility of the substance at the given temperature. Kumasi Sec, your temperature is 25 degrees Celsius.
(3.2 by 10 to an exponent of negative 4.
No. A bonus. Okay. KNUST. 15 degrees Celsius.
Madam, we have 3.0 by 10 exponent negative 4.
No, a bonus. Kumasi High.
Okay. We have 3.1 by 10 exponent minus 4.
No. KNUST. Sorry. Kumasi High. Your own question. 50 degrees Celsius. Go ahead.
3.6 by 10 exponent negative 4.
That's correct. Ejisuman, 5 degrees Celsius. 5.
Okay. You have 1.0 by 10 exponent minus 4.
No. A bonus. Kumasi High.
2.3 by 10 exponent negative 4.
No. Okay. So at 25 degrees, the susceptibility is 3.9 by 10 to the power minus 4. At 15 degrees, it's 4.1 by 10 to the power negative 4. At 5 degrees, it's 4.2 by 10 to the power minus 4. Okay. Another preamble. Express the repeating decimal as a rational number in simplest form. Express the repeating decimal as a rational number in simplest form. Kumasi Sec 2.313131 on and on. Yes, go ahead.
229 divided by 99.
That's correct. KNUST 3.121212 on and on. Go ahead.
103. You have to be 103 all over 33.
That's correct. Kumasi High 2.515151. Go ahead.
Okay. We have 83 over 33.
That's correct. Ejisuman 5.232323. Go ahead.
We have 518 over 99.
Yes, that's correct. Kumasi Sec. Calculate the pressure in a 1.2 meter cube tank containing 8.31 moles of an ideal gas at a temperature of 400 Kelvin.
Okay, so I have the pressure to be of magnitude 2.2 by 10 to the power 3 pascals.
No, and I shouldn't have even allowed you because you are bailed out. Does anybody want it as a bonus? Kumasi High.
We have 23 by 23 kilopascal.
That's correct. KNUST. Determine the temperature at which 4.00 moles of an ideal gas present in an 831 dm³ container will have a pressure of 0.960 kilopascals.
We have it. Kilokelvin.
No. Ejisuman.
Okay, we have 24 Kelvin.
No. I'll come back to the answer. Kumasi High. 7 moles of an ideal gas are present in a container at a temperature of 200 Kelvin and a pressure of 166 pascals. What is the volume of the container? Go ahead.
70 meter cube.
That's correct. Ejisuman, determine the number of moles of an ideal gas present in 831 dm³ container at 300 Kelvin and 1.5 kilopascals.
We have 0.5 moles.
No. A bonus to KNUST.
We have to be 5.00 by 10 to the power 2 moles.
No. Okay, so Ejisuman, you should mind your significant figures. So the answer, your bonus answer you took was 24.0 Kelvin. Your own answer was 0.50 moles. Kumasi Sec. What is the name of an organism that produces its own energy using CO2 and light?
Phototrophs.
No. Kumasi High.
photosynthetic organism.
No. Okay, so I have photoautotroph. KNUST. How do chemoautotrophs acquire energy?
Chemical.
Go ahead, okay.
Madam, chemoautotrophs acquire their energy by oxidation of inorganic substances in the soil, such as sulfur or hydrogen sulfide.
A bonus. Okay, Kumasi High. Why can humans be considered as chemoautotrophic? Go ahead.
This is because humans obtain their energy from chemical compounds that have been synthesized by plants. So they depend on the chemical compounds such as to obtain energy which have been synthesized by plants.
2 out of 3. Ejisuman, how are fungi chemoautotrophic?
Okay, this is because fungi uses chemicals, like they digest chemicals outside their body by themselves to gain energy. So like they prepare or they produce energy by themselves by synthesizing or digesting chemicals by themselves to obtain energy.
No. A bonus. Okay, so chemoautotrophs acquire energy by synthesizing their own food when they fix carbon dioxide. Humans can be considered chemoautotrophic because they obtain energy from plant and animal sources. Okay, that's why I gave you 2 out of 3. Ejisuman, fungi are chemoautotrophic because they gather food from their environment. Okay, that brings us to the end of round 1.
Enjoy high performance at the same price with the Super XP Ron 95. Goil, good energy. Enjoy high performance at the same price with the Super XP Ron 95. Goil, good energy.
Okay, so there are a few protests with the last set of biology questions. So, Kumasi Sec, I asked what is the name of an organism that produces its own energy using CO2 and light, and they said phototroph. So I did not accept and said I wanted photoautotroph. Okay, so they are challenging that it should be the same. So the little research I have done indicates that under phototrophs, we can have photoautotrophs and photoheterotrophs. And the photoheterotrophs, they do not use carbon dioxide. So if you said phototroph, you are talking about a general group that is not specific to photoautotroph. So I cannot accept that answer. For Kumasi High is also saying I should have accepted photosynthetic organism. That one, no, I won't accept it as their bonus. However, KNUST saying that they started and I didn't even allow them to finish. But they started by saying that chemoautotrophs can break down oxidized compounds like sulfur and get their energy. So it's one of the ways that they can get energy. I'll give them 2 out of 3 for that. In the same way, Ejisuman also talked about how fungi can break down chemicals from their environment and get energy. I'll also give them 2 out of 3 for that answer. So that will bring the scores at the end of round 1 to Ejisuman Senior High School 9 points, KNUST Senior High School 10 points, Kumasi High School 12 points, Kumasi Sec Tech School 12 points. Okay, so that brings us to round 2. In round 2, each question that is read out is open to all the schools at the same time. At any time, if you are convinced you have the correct answer, ring your bell. I'll stop and allow you to give your answer. If you give me the first correct answer, 3 points. Second correct answer, 2 points. Third or fourth correct answer, 1 point. At any time, if your answer is incorrect, there's a penalty point of 1. When you ring your bell, it means you have an answer. So if you ring your bell and you are still calculating and slowing down your answer, if another school rings their bell, I'll move on to them. Okay. Our first question for the speed race. What mass of calcium oxalate, CaC2O4, is present in a 20.0 cm cube solution of the salt of 0.500 mole per dm cube? Kumasi Sec Tech.
Okay, so we have 1.28 grams.
That's correct. Okay. Upon exposure to sunlight, nitric acid decomposes to give nitrogen dioxide, oxygen, and water. What is the sum of the coefficient of all reactants and products in this reaction? Kumasi Sec Tech.
6.
No. Kumasi High.
11.
That's correct. What is the molarity?
Oh.
Kumasi High.
0.0125 mole per decimeter cube.
No. What is the molarity of a solution formed by dissolving 2.84 grams of a salt of molar mass 142 gram per mole in 20.0 Yes, KNUST.
1.0 by 10 to the power negative 3 mole per dm cube.
No. Yes, Sec.
0.100 mole per dm cube.
No. Ejisuman.
We have 0.001 moles per dm cube.
No. I have 1.00 mole per dm cube. Our next question. The sides of a triangle lie on the lines x plus y equals 6, x minus y equals 4, x minus 2y equals 12. Yes.
Okay, so I have 5,1, and then the other one is also, and then the other one is also negative 8, negative 8, negative 12, and then the last one to be,
It's not correct. It's not correct. Who else rang the bell? Kumasi High.
Okay. We have one of the points to be 5,1, negative 4, negative 8, and the last one to be 4, 12, and the last one to be equal to 12, 8, negative 2.
That's correct. Simplify. Okay, so a fraction with numerator 6, denominator, bracket open, square root of another bracket open, x plus 3. So square root of the expression x plus 3 minus square root of the expression x minus 3. That is the denominator. By rationalizing the denominator. KNUST.
We have it to be a fraction with numerator, a fraction with denominator 9 and numerator 6 root x minus 3 plus 6 root x plus 3.
No. Who rang the bell next? Kumasi High. Yes. Go ahead. It's correct. I'll let them answer into the microphone. So, yeah. So, Kumasi High, repeat that answer into the microphone.
We have square root of the expression x plus 3 plus square root of the expression s minus 3.
That's correct. Okay. In a triangle, find the length of an altitude. If the altitude is 3 centimeters longer than the corresponding side, and the area is 27 cm cubed, 27 cm squared area. Yes, Kumasi High.
Minus or plus?
Kumasi High.
Okay, so we have 9 centimeters.
That's correct. What is the name of the actively dividing cells?
Stem cells.
No. Ejisuman.
Meristematic cells.
No. Okay. Actively dividing cells are the tips of plants. Kumasi High.
Apical meristems.
That's correct. What name is given to the collection of seeds in the... Yes, Kumasi Sec.
Okay. You have the stores.
No. Collection of seeds in the soil.
Collection of seeds.
Yes, Kumasi High.
Seed bank.
That's correct. What type of fungi rely on non-living organic matter? Kumasi Sec.
Saprophyte.
I'll take it. The wavelength of a laser beam is 750 nanometers in vacuum. What is the wavelength of the beam in glass of refractive index 1.5? KNUST.
5.0 by 10 to the exponent negative 7 meters.
No. Kumasi High.
500 nanometers.
That's correct. An object moves in a circle of radius 0.50 meters. Find the magnitude of the centripetal force on the object when its kinetic energy is 45 KNUST.
Is 45 Newton.
No. Kumasi Sec.
180 newtons.
That's correct. Our last question for the round. The velocity of a 2-kilogram particle is given by 3 t to the power 5i. all of this meter per second to the power 6. Find the force on the particle at t equals 1 second. Kumasi High. Kumasi High.
30 I Newton.
No. KNUST.
30 meters.
No. Okay, Ejisuman.
30 newtons.
That's correct. That brings us to the end of round 2.
Enjoy high performance at the same price with the Super XP Ron 95. Goil, good energy. Enjoy high performance at the same price with the Super XP Ron 95. Goil, good energy.
Okay, a few protests. So it just shows that everybody is invested and you are really listening. So Kumasi High has challenged the last physics question that I should accept their 30 I Newton answer because I didn't ask for the magnitude, I asked for the force. I agree with them, so I'll give them the mark. So that means they get the first attempt and I take my 2 points back from Ejisuman. Okay. KNUST also, yeah, they are challenging their answer to the physics question, the wavelength. Yeah, so they gave me the standard expression and they are right. 5.0 times 10 negative 7 meters is the same as 500 nanometers. So I would accept that as well. Yeah, I'll accept it. So that brings the scores at the end of round 2 to Ejisuman Senior High School 6 points, KNUST Senior High School 9 points, Kumasi Sec Tech School 16 points, Kumasi High School 26 points. Round 3. In this round, yes, 1-6. Kumasi Sec Tech is 16, 1-6. Okay, that brings us to round 3. Oh, before we go to round 3, there's a substitution. Ejisuman Senior High School would like Awal Muhammad to come on for Ebenezer Kwarteng. Okay. In round 3, and even before I start giving the rules, the very first important rule you should all stick by is to look at me and give the answers. No looking into the crowd, no communicating with anybody. Because if you are caught communicating, you'll be penalized. So all answers to me, because the questions are coming from me. Is that right? Okay. So in this round, any statement I make to you, just tell me if it's true or false. If you give me a correct answer, 2 points. If your answer is incorrect, a penalty point of 1. If you do not want to guess because you don't want to be penalized and you are bailed out, that is very okay. Another school can ring for your question and then the answer for the same rules. 2 points if they are correct, a penalty point of 1 if their answer is incorrect. Okay? In this round, I'll start with KNUST. Once again, all eyes on me, all answers to me. Okay. KNUST. The shape of water is linear at very low temperatures.
It's false.
Yes, it's false. Kumasi High. The shape of carbon dioxide is linear. Go ahead.
True.
Yes, it's true. Ejisuman. Sulfur dioxide is V-shaped.
It's true.
Yes, it's true. Kumasi Sec Tech. Sulfur trioxide has a trigonal pyramidal shape. Go ahead.
False.
Yes, it's false. KNUST. All isosceles triangles are similar.
It's false.
Yes, it's false. Kumasi High. All equilateral triangles are similar. Yes.
True.
Yes, it's true. Ejisuman, all rectangles are similar.
It's false.
Okay. Kumasi Sec. All regular polygons are similar. Yes, it's false. Okay. Okay. State whether true or false about the cross-section of the named plant part. So these statements are about the cross-section of the named plant part. KNUST. The roots of dicots have no epidermis.
False.
Yes, it's false. Okay. The pericycle is present. It's present. So in the root of dicots, the pericycle is present. Yes.
False.
No, it's true. Ejisuman, secondary xylem is present.
It's true.
No, it's false. Kumasi Sec. There are cortisal cells present. CORTISAL. Cortisal cells present.
False.
Yes, it's false. A preamble. Electric charge density. Electric charge density is everywhere zero in a region centered on the origin. Okay, I'll take it again. Electric charge density is everywhere zero in a region centered on the origin. KNUST. The electric field in the region is everywhere zero.
It's false.
Yes, it's false. Kumasi High. The electric field in the region is directed toward the origin. Yes.
True.
No, it's false. Ejisuman. The electric field in the region is directed away from the origin.
It's false.
Yes, it's false. Kumasi Sec. The electric field in the region is uniform.
True.
No, it's false. KNUST. Ca2 plus is larger than SR2 plus. Yes, it's false. Kumasi High. Na plus is larger than Mg2 plus.
True.
Yes, it's true. Ejisuman, Be2 plus is larger than B3 plus. Yes.
It's false.
No, it's true. Kumasi Sec. Si4 plus is larger than Al3 plus.
False.
Yes, it's false. KNUST. The integral of x to the power half dx equals x to the power half plus c.
It's false.
Yes, it's false. Kumasi High. The integral of x to the power half dx equals 3 on 2, multiplying x to the power 3 on 2. The power is 3 on 2 plus c.
False.
Yes, it's false. Ejisuman, the integral of 3 on 2 x to the power half dx equals x to the power 3 on 2. The power is 3 on 2 plus c.
It's true.
Yes, it's true. Kumasi Sec. The integral of x to the power 3 on 2. The power is 3 on 2 dx equals 2 on 5 x to the power 5 on 2. The power is 5 on 2 plus c.
True.
Yes, it's true. KNUST. Sclerophis regularis is a toad in Ghana.
It's true.
Yes, it's true. Kumasi High. Frogs are warm-blooded.
False.
Yes, it's false. Ejisuman, frogs and toads are anurans. Frogs and toads are anurans.
It's true.
Yes, it's true. Kumasi Sec. Amphibians are anurans.
False.
Yes, it's false. It's the other way around. KNUST, beta particles emitted from the same radioisotope by any decay mode all have the same mass.
It's true.
Yes, it's true. Kumasi High, beta particles emitted from the same radioisotope by the same decay mode all have the same charge.
True.
Yes, it's true. Ejisuman, beta particles emitted from the same radioisotope by the same decay mode all have the same energy.
It's true.
No, it's false. Kumasi Sec, beta particles emitted from the same radioisotope by the same decay mode all have the same linear momentum.
False.
Yes, it's false. And that brings us to the end of round 3. There's a protest here from Ejisuman that their answer that secondary xylem is present in the cross-section of a root dicot should be accepted. But it doesn't happen in all roots of dicots, okay? So like I say, so far as there's one instance that negates the statement, it cannot be true. Okay. So at the end of round 3, the scores are Ejisuman Senior High School 13 points, KNUST Senior High School 25 points, Kumasi Sec 29 points, Kumasi High School 36 points. Round 4. In this round, I'll read out the clues of 4 different riddles for your benefit. At any time, if you have an answer, ring your bell. I'll stop and allow you to give the answer. If you give me the correct answer on the first clue, 5 points. Correct answer on second clue, 4 points. Any clue thereafter, 3 points, okay? Test your bells. Let's make sure. Okay. Okay. Kumasi High. Okay, Ejisuman. Okay. So our first riddle. I am an element found in the Earth's crust. I am radioactive. My isotopes are used in radiometric dating to determine the age of rocks and fossils. Yes, KNUST.
Carbon.
No. Ejisuman.
Sulfur.
No. Okay. I am one of the heaviest naturally occurring elements. My isotopes are used as fuel in nuclear reactors to generate electricity. Yes, Kumasi High. Into the microphone.
Uranium.
That's correct. Our next riddle. I am a physical quantity. I am a vector quantity. I am used in defining a force. Force is my rate of change. Kumasi Sec.
Linear momentum.
That's correct. Okay, our next riddle. I am a Latin word. I am a Latin word. I am found in different forms when used. I form part of the scientific name of different organisms. I show how beautiful organisms are. I literally mean beautiful. Who am I?
How beautiful what? Elements.
KNUST.
Genus.
No. Kumasi Sec.
Sapien.
No. Kumasi High.
Okay. Finus.
No. Who am I? Ejisuman.
Oh, say name. Binomial nomenclature.
No. Okay. So it's pulcher. Pulcher. Our last riddle. I am a region of space with distinctive properties. Yes.
A circle.
No. I am distinguished by the effects I produce on electric charges. I can cause charged particles to accelerate. However, I am Kumasi High.
Have electric field.
No. However, I am incapable of changing the kinetic energy of a charged particle. An example of me is the region surrounding a bar magnet. Who? Ejisuman.
Magnetic field.
That's correct. That brings us to the end of round 4. At the end of round 4, the scores are Ejisuman Senior High School 16 points, KNUST Senior High School 25 points, Kumasi Sec Tech School 32 points, Kumasi High School 39 points. With that score, Kumasi High School wins this contest. Congratulations, Kumasi High. They were a seeded school and they proved themselves. Okay. Best wishes and better luck next time to our other competing schools. Thank you for joining us for the Girl Regional Championship from the Ashanti region. Do join us when we bring you the next contest. The Girl Regional Championship is proudly sponsored by GOIL with support from Joy News.